Have a look at the first five MCQs of paper number 4, right? Now, if you understand a source is placed at the center of a glass sphere, right? And it is placed inside a liquid, right? Now, you should understand since this source is placed at the center, there will be no refraction at this interface, right? The main reason is the ray which is going to travel through this is going to be perpendicular to the surface, right? If a line joining the center and the tangents are going to be perpendicular, right? So this ray does not get refracted at this interface. That's the important thing you should know that, right? So the ray which is supposed to be moving without refracting, right, reaches the water level, and at the critical angle value, you're going to have your radius, right? And this would finally end up with a conical shape, right? So if you understand for the radius, you can just get into an answer. If this is the critical angle C, it's going to be as it is at here, C, right? Now if I find an expression for C, you should understand sin C is equal to 1 over n, and the refractive index of water is 4 by 3, right? So sin C is supposed to be a value like 3 by 4, right? And we should know that cos C is supposed to be equal to 1 minus, cos squared C is supposed to be equal to 1 minus sin squared C, right? So from that, we can end up with an answer for cos C as well. Now this is going to be for cos squared C, and cos C is supposed to be equal to root 7 over 4, right? So if you found tan C, it's going to be 3 by root 7, right? You should understand sin C upon cos C, right? So tan C is equal to 3 over root 7. And if you found the tan C here, it's going to be opposite over adjacent, which is r over this height. Now if you understand entirely, it's going to be 16 root 7. The radius of the sphere is root 7. So this remaining distance is going to be 15 root 7 over r. So finally we would end up with the answer is equal to 45 centimeter, right? So if you look at question number 2, now you should understand in this sort of question, now even though if it is physics, this is going to be a first order reaction according to chemistry, right? So the half-life of this equation is supposed to be equal to, now you should understand initial concentration divided by final concentration is supposed to be equal to 2 to the power n. Now n is going to be the number of cycles, right? And from this we can get an answer. N times of t half is supposed to be equal to the total time lasted, right? Now first of all we have to find the t half for this question. Now you should understand after 12 days the concentration has been 1 by 8 of the initial, right? So if I take a ratio 1, let's say it has a naught as the initial concentration, the next one is a naught over 8, which is supposed to be equal to 2 to the power n. So from here we can get n is equal to 3, because 8 is going to be 2 to the power 3, right? Now when n is 3, you should understand 3 times of t half, which is here, 3 times of t half is going to be equal to 12 days. That means after 3 cycles, now it's a first order reaction, times t half, it's going to be 12 days. So t half is going to be 4 days, right? So they're asking us at the end of 20 days, what's going to be our concentration. So again, we have to find how many cycle has passed through. Our half-life is going to be 4, and the number of days which has lasted is 20. So n times of, let's say it has n1, because we has taken n here, n1 times 4 is supposed to be equal to 20. So from here we would get n as 5. Now if I back again plot in the same equation, initial concentration over final concentration is supposed to be equal to 2 to the power 5. From here we can get the final concentration as initial times 2 to the power 5. So you should understand it's going to be 1 by 32, right? So now let's have a look at question number 3, right? Now this is going to be a question based on center of mass, right? Now usually you should understand when we are dealing with some object like circles, disk, we used to consider the surface density, mass per unit area. And when we consider like rods, we used to consider mass per unit length. So let me just write it. Mass per unit area. And rods, we are going to have mass per unit length. And probably now cones, cylinders, we used to consider mass, the density, mass or volume, right? So if you understand, we have to, let's say, rho be the density, right? So if you understand, the density of the small cylinder is going to be pi a squared times the height is supposed to be 2a times rho. And you should understand in a cylinder, the center of mass is going to be at the center. So it's 2a in the sense it's going to be exactly at a from here, right? So you're going to have a mass of this. So let's say that mass is m, right? And if you understand for the large cylinder, the radius is supposed to be 2a. So it's going to be pi times 2a squared is 4a squared times this height is going to be 4a. So it's going to be 16a cubed times rho, right? So you should understand if this is m, this is supposed to be equal to 8 times of m, right? So you are having m along here. Now this is going to be 4a, so it's going to be exactly at the center. Now from here, if you understand, it's going to be at 8m, right? Now when we have added some mass, we can add both of them. Now the center of mass is going to be exactly in between these 2 points when we have added a mass. But when we have removed a mass, the center of mass is going to be towards the large mass. That means away from the large mass. So it's going to be around somewhere around here, right? But to ease our calculation, we can just consider the center of mass along here. It won't be a problem, okay? Now you should understand there's a mass removal. So the mass along here is going to be 7m, right? Exactly 7m is supposed to be along here. But to ease our calculation, let's take it around here, right? So you should understand the ratio is supposed to be 8 is supposed to be here and 1 is supposed to be here. And if I found the center of mass from this point, it's going to be 8 by 7. Now this distance is a, this remaining is also a. So from this point, it's going to be at a distance of 8 by 7a, right? From here. And the distance from here is going to be, this point was a, right? Capital A. From capital A, it's going to be addition of a, right? A plus somewhere around here, 8 by 7a. So from this, we would get 8a by 15, right? Now the problem which I want to say here is, if I measure the center of mass from here, we won't get an exact answer. As I said, the center of mass lies along here. We have to add this answer, right? Now, this entire distance is 2a, right? And the center of mass is located from here at a distance of 1 by 7a. So to find the center of mass, we have to add 2a plus 1 by 7, right? So you should understand that case, okay? Now if we have added mass, we have to subtract it. If I have added this cylinder to here, then it's going to be 9m here. 1 by 9 is supposed to be the subtraction of 2a. But the center of mass exactly existed around this point. To ease our calculation, we were using along here. So we have to add this value, right? So that was the only problem which I want to say. So the center of mass is going to be at a distance of 8a by 15. Sorry, 15a by 7. 7 plus 8, 15a by 7. Right? So it's going to be somewhere around this point. Right? So if I hang this object in a string along this edge, the line of action of this goes through this point. So this angle is supposed to be equal to theta. Right? So if I take tan theta is supposed to be equal to opposite over adjacent. The center of mass is exactly at a distance of 15a by 7 from this point. So adjacent is 15a by 7 and the height is supposed to be 2a. So we would get 14 by 15, which is equal to our tan theta. So from here we can get our answer as theta is equal to tan inverse 14 by 15. So right, now have a look at question number 4. So let's have a look at question number 4. Now in this, we have been given with 3 vessels and with equal cross-sectional area at the bottom, and they are filled with equal volume of water, right? And they have been questioned the resultant force acting on the surface of the walls. Now if you look at C, the resultant force acting on it's going to be 0. The reason is, you can see one force is going to be in the negative x direction, that means towards the left side, and the other is going to be towards the right side. So anyways, they are going to cancel off. So along the surface is going to be 0. But if you look at the normal reaction, or as the force exerted at the bottom, that means it should be in the downward direction, it's not going to be 0, because that's going to be balancing the entire weight of the water, which means if I just name it as capital R is supposed to be equal to V rho WG, right? But anyways, the force acting at the surface is going to be 0, right? And if you look at A, if I enter the beaker C onto this, it would be something like this, okay? Because they are having the same cross-sectional area at the bottom. So same cross-sectional area, you can see it's at a height difference of h2, right? Now you can see this section is fine, and the volume of water which was supposed to be here has been moved to these two corners. If you consider the volume of water at these two corners, except here, okay, entire volume is V. The volume of water along this section would be A times of H1. Because why? You can see the entire volume is V along here, right? If you consider a portion along this, the cross-sectional area is A, and the height along here is going to be H1. So the volume of water along here is going to be AH1. And that volume of water has been moved to these two corners. So it's going to be AH1 rho WG, which means that's going to be the weight which is exerted along these 2 points, right? If you understand, again, the horizontal component cancel off, the vertical components remain. The vertical component must be equal to the weight of the force. And the weight along these 2 points would be AH1 rho WG, right? And if I just give you an extra, it would be in the downward direction. And if I just give you an extra information, what would be the normal reaction, or else the force exerted at the bottom of the surface? Now initially you can see it was V rho WG, but in here you can see AH1 rho WG is present along these two corners. Entire volume is V. So the volume of water along this section would be V minus AH1 rho WG. That will be the volume of water along this section. And the weight of water along that section, sorry, AH1 within brackets, okay, V minus AH1 rho WG. So that's going to be the volume of water along this section, and the weight which was supposed to be around this point is going to be this, right? And if you look at B, it's also the same. If I insert this beaker C onto here, we would have an extra height AH2, right? So A times of H2 amount of water is supposed to be along these corners, right? And that would be the force, which means AH2 rho WG, and that would be in the upward direction, right? Again, understand, when I just enter this beaker C onto here, we would have an height difference of H2. That means a height greater than this. So if I had A times of H2, we would be able to cover that height, right? So that amount of volume of water is present along this section. So it's going to be AH2 rho WG as the upward force as a resultant. And what would be the normal reaction, or as the weight force along here? That would be equal to the entire volume is V minus AH2 rho WG, right? But anyways, they have been questioned about the force acting on the surfaces. So that has to be AH1 rho WG in the downward direction, AH2 rho WG in the upward direction, and along here it's going to be 0. So it's going to be answer number 1. Let's have a look at question number 5. Now, before coming to this question, just make sure that you're going to check 1994, I think. Yeah, 1994. We had an MCQ related to this, right? And the question in that was, which is not possible to have a resultant of 0, right? Now, if I just give you the theory behind this, now we are going to have some small forces in between as well as a large force. Now, in this triplet, right? So the summation of the two small forces should be either greater than or equal to the large force. So that has to be the requirement here to have a resultant of 0, right? Now in this case, if you understand, summation of 5 plus 5 is 10 and it's greater than 5. So we can have a 0 resultant force. If you see here, now we are having 5 plus 5 which is 10 and 5 plus 3 which are the two small forces, and the summation of them is 8 and it is greater than 5. So in this case also we can have a resultant of 0, right? If you see here, 5 plus 4 is 9 and it is also greater than 5, right? Now if you consider in this question, everyone are going to be greater than or equal to the value. So in here the resultant is possible. Resultant is equal to 0, right? But let me just give you an example like 5, 3 and then 20. Summation of these two is 8. Now this is less than 20. So now in this case we won't be able to get a resultant of 0, right? So for the case of parallelogram of forces, they must be in equilibrium, which means the resultant has to be 0, right? Now in all of these cases we can have a possibility of resultant being 0, right? So, but if you understand this answer 5, 3, 2, the only position we can have this in equilibrium is we can have 3 Newton and as well as 2 Newton in upward direction and 5 Newton in the downward direction, right? This is going to be the only possible way we can get a resultant 0 in this case, right? So I think this is going to be the answer which is wrong, okay? Because we cannot verify this using the parallelogram law. Now, when you are because in a parallelogram law, we must be able to represent them in a vector notation. That means finally they would be in a parallelogram shape. Two vectors would be there and they would be ending up in a parallelogram way. If I just draw the vector triangle for them, if we start from one vector, 3, and where it ends, start the other vector, where we have 2, and from here to here we have to draw back again a point. Now this is in equilibrium, right? But you can see there's not a parallelogram formed. It's just going to be a straight line. So this is going to be our answer, right? So it's better to check 99 for that question. The theory behind that is summation of two small forces has to be greater than or equal to the large force. So in that case, we can have a resultant of 0.